Hi math students, in this video we're just looking at a start to finish process of factorising a cubic function using our very favourite fun-filled polynomial long division technique. So as an example, I've just got here fully factorise and solve this cubic, showing full algebraic working. So we can see that this cubic function is in the form ax cubed plus bx squared plus cx plus d. And in an earlier video, I showed you how it's important to locate the coefficient to the x cubed, a, and then the constant d at the end here. They're our trick to factorising this cubic. So if I have a quick think about this, if I look what's next to the x cubed, hopefully you've identified that there's a 1 there. It's not written there, but there is a 1 there. So 1 is the a value, and that at the end here, this plus 10 is our d value. So the second step, once you've identified the a and the d, multiply them together. So I've got 1 times 10, and that gives me 10. And then from there, I need to think about what are the factors of 10. So I can list them out and go, look, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. I've written these out because I know that 1 times 10 gives 10, negative 1 times negative 10 gives 10, 2 times 5 gives 10, negative 2 times negative 5 gives 10. So all of those are possible factors. So that means I want to kind of start by testing the lower end of those factors. So I would probably start off by testing x plus 1, then maybe x minus 1, x plus 2, x minus 2, and if I needed to, I'd keep going. And remember kind of thinking that reverse null factor law. If I looked at x plus 1 equals 0, what I'm actually substituting into the function is x minus 1. If I tested x minus 1 equals 0 into the function, what I'd actually be substituting in is x equals 1. And remember, the idea here is to test it, I substitute in the value I'm interested in. So for example, x equals negative 1, and I'm seeing if that gives an overall value of the function of 0. For this first test, I'm going to test the first one I suggested, x plus 1, as a factor. So if I define my function as I was given, just substituting f of x instead of 0, I'm going to test my reverse thinking type null factor law. I'm testing x equals negative 1 to see if I end up with 0 as a result. So if I pop that in, negative 1 cubed minus 4 by negative 1 squared minus 7 by negative 1 plus 10. So if I have a look at that, I've got negative 1, take 4, plus 7, plus 10. And that gives me a value of 12, which is not 0. So I know that this factor here fails. So moving on to my next, testing x minus 1. So rearranging that, I know I'm actually substituting x equals 1 into my function. So testing that, I've got 1 cubed, which is 1, minus 4 by 1 squared, which is 4, minus 7 by 1, which is 7, plus 10. So 1 minus 4 minus 7 plus 10 gives me 0. So I know I have a winner, chicken dinner. And x minus 1 is a factor. Okay, now for the fun bit, the polynomial division of our factor x minus 1 into our cubic that we want to factorize and solve for. So, if you can recall, this is that forward and reverse cycling back process where you start with the x and you're trying to divide it into the x cubed to kick things off. So essentially I'm asking, how many times does x go into x cubed? So hopefully you think x squared. So that's kind of my forward process. And then I need to work backwards, cycle back, and go x squared times by x will give me x cubed. And in the cycling back, I also have to apply that to the -1 there. So x squared times -1 gives negative x squared. I rule it off. I then do my subtraction step. So x cubed minus x cubed gives me 0. Moving over to the squares here, I've got minus 4x squared minus x squared. So really it's saying minus 4x squared plus x squared. So I'm going to have negative 3x squared. And I start things off again. So with the x, how many times does x go into negative 3x? I know you're all thinking, well, that's just going to be negative 3x. So then if I cycle back, negative 3x times x gives me negative 3x squared. Negative 3x times -1 gives me positive 3x. I can't forget to bring this guy down to join the fun. So minus 7x. Rule it all off for subtraction. Negative 3x squared minus 3x squared. So negative 3x squared plus 3x gives me 0. Negative 7x minus another 3x gives me minus 10x. And we start off the forward process again. So x now into negative 10x gives me negative 10. Cycling back now, I've got negative 10 times by x gives me negative 10x. Negative 10 times by -1 gives me positive 10. Bring this guy down for the last part of the question. Do my subtraction step. 10 minus 10x minus 10, so plus gives me 0. 10 minus 10 also gives me 0, and I've finished my division part. Okay, last part. So I've factorized out x minus 1, and you can see here I've got a quadratic left over that I need to further factorize. So I continue this factor in. If I have a think about it, what factors of negative 10 add to give this negative 3x in the middle? Because remember, this is what we're trying to split up. And hopefully you've thought, look, I know that negative 5x and positive 2x add to give negative 3x. And if I think about it, negative 5 times 2 also gives me negative 10. So if I split that up, factorize each half, highest common factor on this side's x, highest common factor on this side's 2. So I've got x outside of x minus 5, 2 outside of x minus 5. You should be able to see that a highest common factor to both this term and this term is now x minus 5. So that gives me my finalized factorized cubic ready for solving. So now I can go in, apply my null factor law. So remember, the really simple way of thinking about this is each factor becomes equal to 0. And my 3 solutions for this particular cubic can be x equals 1, x equals 5, or x equals -2, which is a great way to find the x-intercepts of this particular cubic.